So how in the world are we going to do this? Believe it or not, it's not that hard. Okay? It's actually much, 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 much easier than the numbers. Okay? Probably the best thing is to remember some of the properties of powers. Do you guys remember that, like, x to the a power times x to the b power? Do you guys know what you do with the exponents there? Do you guys remember what you do? You have two powers with the same base. This is the base. This is x to the a plus b power. In other words, x to the second times x to the third would equal x to the what? 2 plus what? 3 power, which would equal x to the what? Fifth. Really, Chelsea? That's brutal. This is 2 plus 3. Basically, any time, what would the answer be here? X to the what power? X to the 12th. The easiest way to understand this is realize that powers are basically an abbreviation. X to the 5th is an abbreviation for what? X times X times X times X times X, right? X to the 7th is an abbreviation for what? X times X times X times X times X. How many is that so far? Times X times X. Please close the door. So now, instead of just multiplying 5 x's together, or over here 7 x's together, when I multiply them together, I'm now multiplying a total of how many x's together? You see, that's why you add the exponents? Everybody make sense? That makes sense? All of this is getting to this fact. Square root of x to the second power. I'm asking, what could I square and get x squared as the answer? What is it? X to the first power. I know you don't write the first, but we understood that that's a first, don't we? So the square root of x squared is x to the first. You know what the square root of x to the fourth is? X to the second, because x squared times x squared is what? X to the what? You know what square root of x to the sixth is? 3. No, that's not 3. Well, x to the third power. There we go. It's x to the third power. It's not even remotely close to the same thing. But I understand what you meant. What do you think the square root of x to the 8th is? X to the 4th power. What, is there a pattern forming here? Square root of x to the 10th power. What do you think it is? What do you think the square root of x to the 100th power is? Huh? X to the what? 50th power. Stop. X to the 50th power. What do you think the square root of x to the 500th power is? That's easy, isn't it? All of those are perfect squares. Now, we did all of these. However, can you guys answer that question? Basically, when it comes to variables, what did all of these have in common with the exponents here? They're all what? Even numbers. What is that? You need to simplify this. And here's what you're going to do. You're going to say, what is the largest perfect square that's a factor of x to the third? Same as you have been. The nice thing about it is, what's the closest to x to the third? Square root of x to the second times square root of x to the first is how you'd break that up. Because together, when you multiply them together, don't you get x to the third? And what is the square root of x squared? So x square roots of x is what your answer would be for that. Now let's try square root of x to the fifth. Is that going to come out even? Is that a perfect square? No. Because the exponent is what? Odd. However, though, finding the perfect square that's a factor of it is very easy. It's always going to be whatever that exponent is minus 1. So I'm going to break this up into, instead of x to the fifth, it'd be x to the fourth times square root of x. Do you see how when I multiply those back together, I get that? Does everyone see that? Everyone look up here. I'll pause, I'll freeze this and let you write it down. Right now I would like you to follow with me, so put your pencils down. All pencils down. You see how I broke this up to where when I multiply them back together, I do get that, don't I? All eyes up here. X to square root of x to the fourth. What is that? X what? So I got as much as I could out. What's left inside? Square root of x. That's your answer there. Keeping your pencils down. Square root will go up to x to the seventh this time. What do you think? How am I going to, that's odd, so it doesn't come out perfectly, does it? But it's easy. All I have to do is subtract 1 from that number. You know what the large perfect square it's a factor of is? X to the sixth times square root of what? X. See how easy that is? What's the square root of x to the sixth? X to the third x. Your answer there. Stop writing and listen. Questions so far? Do you see a pattern for me? How about we try square root of x to the ninth? What happens there? I would split it up into square root of x to the what? Eighth times square root of what? See how those multiplied together gives me that? What's the square root of x to the eighth? Pretty easy. Here I had square root of x. Let's try square root of x to the 11th. What do you think I'm going to be my perfect square? Break it up. X to the 10th times square root of what? What do I get? X to the 5th square root of what? Keeps getting easy, isn't it? How about x to the 101, square root of x to the 101st power? What am I going to do now? Pencils down. Eyes up here. Square root of x to the 100th times square root of x. So I get x to the 50th square root of what? How about square root of x to the 501 power? What do you think I'm going to get here? I'm going to split it up into square root of x to the what? 500 times square root of what? X. So I'd get x to the what? 250th square root of x. Write that down. So if the variable has an even number, you can take square root of it, can't you? It comes out even. If it has an odd, you split it up by taking one less and leaving square root of x, right? Super easy. That's what I mean. How, other than getting over the fact that it's variables and maybe being confused by the letters, the actual math you're doing on these is simple. So if you look at it this way, you're always going to be able to get all the variables out except for one of them when they're odd, right? There should be one variable left over. And would any of these rules change if I made that a to the second, x, a to the fourth, a to the sixth, or s, or whatever? I just changed the letter I'm using to represent a number. That's the next thing we're going to do right here. Example of this. When I see your pencil stopping, I know you got everything written down. Put that up. Amazon. You have to have a phone that will charge like that, though. Just to have wireless charging capability. Now, looking at this one. Here's the deal. Does this look complicated? Maybe as a whole just because there's a bunch of stuff, but when it's all said and done, it's basically three separate problems. You're going to simplify that, then you're going to simplify what? That, and then you're going to simplify what? That, and you're going to put it all back together, what's on the inside and what's on the outside. X to the fifth, I'd break that up into square root of x to the what? Fourth times square root of what? Y to the 10th. That's even. So I can just write now that's y to the what? Without the square root sign, correct? Because the square root of y to the 10th is y to the 5th. Is this odd or even exponent? So times square root of z to the second times square root of z. So that came out of the square root. What happens here? So this becomes what? X what? To the second. That comes out of the square root. This becomes just a plain what? Z. So what I'm left with is x to the second times y to the fifth times z times square root of x times square root of z. When you combine everything back together, what are you left with? X to the second, y to the fifth, z. What's on the square root side? X, z. All I have to see is this right here. You could have gone from right here to right there. You could have gone from here to here, but I do need to see that everything split up. You don't necessarily have to write this down and split it up. I was just showing you how it's basically three different problems. Okay? Everybody okay with that one? It's really not that bad, is it? Now, here's what we're going to do. I'm going to make another problem very, very similar. What's the difference between these two problems? I put an actual number in. So as far as what type of problem this is, the only thing that changed is I'm going to do a problem like this, which is from the ones we have been doing, right? And then I'm going to simplify x to the fifth, y to the 10th, and z to the third, right? Think of it like this. Like I said, it's just four problems in one, isn't it? Think of them separately, then combine them. How would I simplify square root of 75? Is that a perfect square? What's the largest perfect square? It's a factor of it. So that'd be square root of 25 times square root of 3, right? Good, I've broken that up. How would I break this up? Square root of x to the fourth times square root of what? X. How would I break this up? Well, it just becomes y to the fifth, doesn't it? And here I'd break this up into square root of z to the second times square root of z. So, outside of the square root, what does square root of 25 become? That becomes that right there. Everybody pay attention. Is that everybody okay with that? Stop writing. Just let me at least finish it. And listen to me and watch do it. Everybody understand square root of 25 becomes 5, right? Okay, this is inside the square root, right? So that goes to there. How about square root of x to the fourth? What does it become? So that becomes x squared. That becomes goes right there, right? Where does this x go? Inside. Y to the fifth. That's outside, so that just gets moved to right there, doesn't it? Everybody okay there? Over here, what about this? Square root of z squared, what does it become? So that goes right there. And then what's left inside? So as you can see, your answer is 5x squared, y to the fifth, z, square roots of 3xz. That's a mouthful. It's just a big mess, isn't it? It's not that hard. Headphones out. It's just a big mess. Any questions? As you can see, look at your assignment, this worksheet. They're a little bit easier than the one I just did, aren't they? First thing I'm asking you to do, write your perfect squares on the front and the back. This would make it a total of 8 times I've made you write them, so I'm making you get to know them, aren't I? That is part of your assignment. If you didn't write them at all on the other pages, the best you could get was 7 out of 10. Why am I doing this? The more times I make you write it, the more you'll remember them. Write your perfect squares on the front, and then write your perfect squares all down on the back. Yes.
Do you want a perfect square so then 400?
Yes. So let's get to work on this worksheet.